Alrighty, so we are going to now learn the third method for solving quadratics. Remember, we're still trying to find the roots, so we're still trying to find the x-intercepts for a quadratic. That's still the goal. We have learned to solve by graphing, and we have learned to solve by factoring. So now the third method is by square roots. And really, this is probably the easiest because you've actually already done it before. So if you look at number 1, to solve using your knowledge of square roots. Well, again, if we're just trying to work backwards, we're able to do that on number 1 because there's only one x in the problem. So I'm just going to square root both sides, and x equals 15, and x equals negative 15. Remember that there's two answers, because most likely there are two roots. And when you square root something, there's both a positive and a negative answer. You could also write this as plus or minus 15. This little symbol right here just shows that there's actually two answers in one. It's a positive and a negative answer, okay? So again, you kind of already knew how to do that. The second one, same thing. We are able to solve this by working backwards because there's only one x right here. So I'm going to add 25 to both sides. So 4x squared equals 25. Divide by 4 on both sides. X squared equals 25 fourths. I'm not going to change that to a decimal. We square root both sides again, so x would equal, square rooting this fraction, remember go back to your radical days, we're just going to square root the top and the bottom, and we're going to have plus or minus 5 halves. Square root of 25 is 5, square root of 4 is 2. Okay, and the last one here, again, just going to work backwards, so I'm going to subtract 100 from both sides, so x squared equals negative 100. I'm going to take my square root. And here's where we have to stop, because you cannot take the square root of a negative number. There's no way to multiply something times itself and get a negative. So my official answer would be no real solutions, which makes sense. Okay, if you think about this equation right here and think about transformations, this is just the parent function shifted up 100. So we've literally got the parent function floating way up there. It's not crossing the x-axis. Okay? This is literally the extent of what topic 5 is about. You're just working backwards because you will only have one x in each of your equations. If I go back to an equation like 4x squared minus 3x plus 9 or something, again, I cannot solve this by just using the square roots because there's two x's. It won't work, okay? If you just have one, though, you're just working backwards. That's really all this topic is about. So number 4, again, subtract 5, x squared equals 0. Take the square root. Well, square root of 0. What times what gives me 0? It has to be the same thing. Well, just 0. That's it. Okay? That would be the one and only root for this situation, which again, if you think back to this original equation and transformations, if I subtract 5, I've got x squared equals 0. Well, that literally is the parent function. And the parent function sits at the origin, so it just has that one root. Okay? Now, here's where things get a little bit interesting. On number 5, again, we are wanting to work backwards to solve for x. Well, x is inside of these parentheses. It's being blocked by a couple bodyguards. We need to get rid of this 4 before I can enter into these parentheses and get the x by itself. I'm going to divide both sides by 4. Okay, slowly but surely chipping away here. Now, again, it's still kind of blocked by bodyguard of this 2, this exponent of 2. So actually, this is the time in which we're going to take the square root of both sides, okay? When I do that, I get x plus 2 left over, because that's taking away the exponent of 2. And then on the right-hand side, the square root of 81, that's both 9 and negative 9. So notice I've now created two separate equations, okay? I'm going to subtract 2 and x equals 7, and subtract 2 and x equals negative 11. Notice it is not just positive 7, negative 7. It's not positive 4, negative 4. It's literally two completely different answers, okay? Which makes sense. If I think about a graph, it's not like they're always perfectly centered right here in the middle. Sometimes they've been shifted over a little bit, right? When that happens, you get roots like this, where you've got negative 11 down here and positive 7 right here, okay? So let's try the same thing on number 6, very similar. Again, I'm trying to get this x by itself. So I'm going to work backwards. I'm going to divide by 2. It's our bodyguard here. So x minus 10 squared equals 100. I'm going to take the square root of both sides. So x minus 10 equals 10, and x minus 10 equals negative 10. Two separate answers here. Then I'm going to add 10 and add 10. So we get x equals 20 as one of our answers, and x equals 0 as another one of our answers. Okay? Continuing right along. Feel free to pause this and try these two on your own. They're exactly like the last two we just did. If you're still kind of confused, I'm still going to keep teaching right through it, but feel free to pause and try them on your own if you're feeling comfortable. So I divide by 5. So x minus 1 all squared equals 36. And square root both sides. So x minus 1 both equals 6. And it could equal negative 6. Then I add the ones. So x equals 7. Or x might equal negative 5. Those would be my two roots. Okay, this side, divide by 16 on both sides. So x plus 5 all squared equals, ooh, woof, let's see, 16 times 7. Let's see the abundance, it's a little too high, so it'd be 16 times 6. I don't have my calculator on me. So 6, but it's 64, huh? There we go. All right, equals 64. Ignore all that. It's my scratch work. Square root both sides. So x plus 5 either equals 8 or it equals negative 8. So I'm going to subtract 5, subtract 5. So x equals 3 or x equals negative 13. Again, two separate answers there. Alrighty. Now, this one you'll notice has slightly different instructions. It says still solve them, but it says round your answer to the nearest thousandth. So as you'll see in just a second, these aren't going to come out quite as evenly as the ones that we've been doing. You'll see once we get started. So on number 9, again, I'm going to try to get this x by itself. I'm going to subtract 80 on both sides. So negative 80 equals negative 2x squared. Still trying to get the x by itself, so I'm going to divide by negative 2. So 40 equals x squared. When I take the square root of both sides, here's where the calculator comes into play. The square root of 40 is not a whole number. We know 6 times 6 is 36. We know 7 times 7 is 49. But that means the square root of 40 is somewhere in between 6 and 7. So if I get a calculator and I take the square root of 40, I get 6.3245, so technically 6.325. Okay, that would equal x. However, because I took a square root, that means there's both a positive and a negative answer. So I'm just going to write plus or minus 6.325. Okay? Because both positive 6.325 squared is 40 and negative 6.325 squared is 40. Okay, so same thing on this next one. I'm going to subtract 90 from both sides. So negative 3x squared equals negative 90. Divide by negative 3. So x squared equals 30. Take my square root. Again, square root of 30 is not going to be a whole number. So type it in my calculator, and I get plus or minus 5.477. Okay? All right, so now let's do some word problems, knowing that we're going to solve them by using square roots. So number 11 says, for a scene in a movie, a sack of money is dropped from the roof of a skyscraper. I'm just going to draw a little picture here. Here's our skyscraper. It's dropped from the roof, goes down like this. Notice that's half of a parabola, okay? The height of the sack above the ground is given by h equals negative 16t squared plus 576, where t is time in seconds. How long will it take the sack to reach the ground, okay? Well, here's my equation. Right now it's got two variables, so I can't solve it right now. But I've got the ground as my desired point. Well, that's a height. That is a height of 0 because it's the ground. So here is my equation that I'm trying to solve. Because I only have this one variable, I can just work backwards. If I had an extra t in there somewhere, I would have to graph it or I'd have to factor it. But because I just have one, I can actually just work backwards. So I'm going to subtract 576 from both sides. Okay, I'm going to divide by negative 16. Use my calculator this time so you don't have to wait on me. We get 36. Now I can take my square root of both sides, and t should equal both positive and negative 6. However, because this is a word problem, we want to consider the context. It's saying how long will it take the sack to reach the ground? Well, 6 seconds or negative 6 seconds. Negative 6 seconds would be going backwards in time, so we're not going to use that one. We're going to just say positive 6 seconds. Okay, but again, just to recap, I took the equation that they gave us. They asked me about the ground, so then that created an equation that I could solve and work backwards. Number 12, a zookeeper is buying fencing to enclose a pen at the zoo. The pen is an isosceles right triangle. There's already a fence on the side that borders a path. The area of the pen will be 4,500 square feet. The zookeeper can buy the fencing in whole feet only. How many feet of fencing should he buy? It's actually a pretty challenging problem. You kind of have to take it one step at a time. The one piece of information they gave us was the area, right? Well, if I'm talking about the area of a triangle, even though I have no clue where this is headed, I'm going to go ahead and just write the area formula, 1/2 base times height. And starting there can kind of get the ball rolling and figure out if this is going to turn into a quadratic, if this is just a linear problem, etc. So the area is 4,500. I'm going to go ahead and put that where my A is. 1/2 is just going to stay at 1/2. But then let's think about the base and the height. Looking over here at my picture, the base and the height are these x's here and here, even though it's not actually on the bottom. Remember that the base and the height have to have a right angle. So x is my base, x is my height. So x times x. Well, we know that x times x is actually just x squared. So I've got 4,500 equals 1/2 x squared. Well, here's the quadratic equation that now I can work backwards and solve. So to get rid of the 1/2, I'm going to multiply both sides by 2. So I've got 9,000 equals x squared. At this point, all I have to do is take the square root of both sides. And I'm going to get 30 equals, no, that's a lie. I think it's 30, but it's really not. That would be 900. I get a decimal, just calculating. 94.868 as my x, which again, positive or negative. However, because this is a problem about a fence at a zoo, it's going to be a positive, because we're not talking about negative length, right? So it's going to be a positive 94.868 for x. However, again, how many feet of fencing should he buy in order to make this pen? Well, we have 2 sides here that he has not put fence on yet. So this needs to be doubled in order to incorporate both sides of the fence. So you end up with 189.737, if we round correctly. Okay, again, I'm using my calculator here. You do not have to do this kind of stuff in your head. Alrighty, I think just 3 more. So again, here's an equation. They've already given it to us right here. This is the height of a skydiver jumping out of a plane. Again, when they jump out, it kind of looks like this. It's half of a parabola. It says how long will it take them to reach the ground? So again, this is just like the problem 2 problems ago. Reaching the ground would be a height of 0. So I'm going to plug that in where my h is. There's only one variable in this problem, so I could solve it just by working backwards. I don't have to factor, I don't have to graph, although you could. So I'm going to work backwards by moving my 3,200 over. Divide by negative 16. Okay, so we've got 200 equals t squared. Is that right? Yeah. Take the square root of both sides. Put up my calculator, and t equals plus or minus 14.142. Which again, talking about a story here, we're talking about time. Well, I don't want negative time, I want positive time. So my final answer would be 14 point, and it says 10th, so 14.1 seconds. That that skydiver is going to hit the ground after 14.1 seconds. Okay, a couple more. A city is planning a circular duck pond for a new park. I'm going to draw a circle. The depth will be 4 feet, and the volume will be 20,000 feet cubed. Find the radius of the nearest tenth of a foot, and then they give us this little equation over here, which you'll notice has a square, so it's a quadratic. So I'm going to go ahead and start with that, and then just plug in the pieces that I know. So volume. They gave us the volume right here, 20,000. Pi is just pi. Radius, I don't know, and in fact, it says to find the radius. So that's just going to say is an R. Times, and the height, in this case is the depth, is 4 feet. So now I just need to work backwards. So I need to divide to get that R by itself. I can actually divide by both 4 and pi at the same time. It says to round to the nearest tenth. So I'm going to go ahead and use my calculator here. 20,000 divided by 4 pi, which the pi key on your calculators is down at the very bottom of your calculator in yellow, so you can use the shift key. And I get 1591.549, and that's equal to r squared. But I'm still trying to find just normal r. So I still have to take the square root of both sides. We take the square root, and we get 39.894, again, positive and negative, as the radius. Well, again, we just want the positive one because you wouldn't say that it's negative 39 feet across or something like that. So I'm just going to go with the positive, and it says tenth, so that's 39.9 feet. Last problem about Beyonce. She would like to display her collection of Grammy Awards on the top of her bookcase shown below. The collection covers an area of 400 square inches. What should be equal for the top of the bookcase to have the correct area? Round to the nearest tenth. So this diagram actually has some extra information. We just care about this part right here. This is where she's going to put all of her Graylys, right? If I look at the bottom of this bookshelf, it's labeled as 5B and B. We're trying to find the area of a rectangle. So again, I'm going to start with my formula. Area of a rectangle is just length times width. Okay? Well, it says area is 400 square inches. Length and width is over here on the diagram. That's the 5B and the B. Which again, we know that B times B is B squared. Oops. So now I just work backwards. Divide by 5. So 80 equals B squared. Then I'm going to square root both sides. This is obviously going to be a decimal because 80 is not a perfect square. So B would equal plus or minus, let's see here, square root of 80, 8.94, so I'm just going to leave it at 8.9. And again, we're talking about a distance here, a length. So we don't want to deal with the negative. We want to just go ahead and write the positive, 8.9 inches. That's what B would have to equal. Alrighty, so in Schoology, you will find your homework for this topic. Again, it's just working backwards. You've actually been doing this probably since 7th grade, but it's a little bit different just because now you know about the positive and the negative version. Okay, if I was to give you any sense of or any sort of caution before you start your homework, it would be to look back over the problems like these, like 7 and 8, where again you have to set it equal to the positive and negative answer and then solve. So your answers are not just plus or minus 7 or plus or minus negative 5. It's two completely different answers. Alrighty. Make sure you ask the sub if you have any questions, and I will be back tomorrow to help out if I need to. Feel free to come into tutoring.